Okay, I think we'll be starting with the session now and let people join. So, hi everyone, this is Manish Nath from Extra Universe, and I am going to be your host for today's session. First of all, thank you everyone for taking your time to join us today. Today is the fourth day of our celebration of the World Space Week, and in today's live session, we're going to discuss about the space robotics. And today, to enlighten us on this topic, we have none other than Dr. Shreya Santra with us. She is an assistant professor at Tohoku University and the co-founder and the director of space technology at Spaceonova. We are really glad to have her here with us today. So without any further ado, I'd like to request Shreya ma'am to proceed with today's session. Thank you, everyone.
Thank you, Manish. Thank you, Hex Universe, for the very kind invitation to give a talk for the World Space Week event. And thank you, everyone, for joining today. And hope I'll give you some insights about space robotics and how it can help in sustainable space exploration. As you all know, the theme of World Space Week this year is space and sustainability. So I'll give you a 45 minutes of session on space robotics, and hopefully you will take away with some new knowledge, new insights, and new information that can help you in pursuing this field if you are interested in. So, and I would like to apologize in advance. I have a bit of cold, so I might be coughing in the middle, so please bear with me. Sorry about that. So, let me start sharing. Okay. Can you all see my screen?
Yes, ma'am, it is visible.
Okay. Yeah. Thank you again. As I mentioned, as Manish mentioned, I am Dr. Shreya Santra, and I'm an assistant professor of space robotics, mostly planetary robotics at the Space Robotics Lab in Tohoku University in Japan. And I'm also the co-founder and director of space technology at Spaceonova, which is a space education and research company in India. And we also have courses on space robotics here. So the plan for today's talk would be as follows. I'll give a very brief introduction about myself, and then we will go into what is sustainable space exploration and how robotics can help in that, and the different challenges in this field. Because if you are interested in pursuing this field, I'm assuming that most of you are in undergrad or higher, and you might be interested in this field, because this is a very niche field and not many people know about it. So, but there are so many research topics that are there that can be explored in this field. So something about that. And we will end with a trivia and some information that you can have for your future. So I was born and brought up in Dhanbad, the coal capital of India. And I did my schooling there. And then on, I did my BTech in electrical and electronics engineering from NIT Jamshedpur. I did my master's in space studies at International Space University in Strasbourg, France. And that's where I got to know about all the different fields that are there for space education. So I studied about space engineering, space science, space business, space policy, space humanities, and everything that could be for space. And that's how I got to have this holistic information of how space academia and industry works. And then I chose my choice of stream, which was robotics engineering. And then I did a more deep, a more technical master's come like a research position at in space robotics at the Skolkovo Institute of Science and Technology in Moscow. And then I went on to pursue my PhD in space robotics at the Tohoku University here in Japan. And then, like last year, I graduated and then joined as an assistant professor. And I also co-founded Spaceonova in the last year, and I give courses on space robotics there. So a brief about Space Robotics Laboratory. We are in Tohoku University, and it's headed by Professor Kazuo Yoshida. If you don't know about the Google Lunar X Prize, it was a competition that ran from 2011 to 2018 that had a challenge that some private company should be able to launch a rover to the moon and then collect pictures, travel for 500 meters and collect some pictures and relay it back to Earth. So this was the challenge. And my lab was one of the participants and one of the finalists that took part in this challenge. And ultimately, the competition was called off because of lack of funding. But that's how this lab became very famous. And now, if you know about this company called iSpace, it's in Japan, Tokyo, it was a spin-off out of this team. So, and we continue to work on planetary robotics, and we have different types of research teams in our lab. One is the free-flying space robot, which is the orbital robotics. We have planetary exploration rovers, which are for Moon or Mars or for other celestial body. Then asteroid sampling robotics, and also robotic systems for the International Space Station, like for robotic arm or for robots that are inside the International Space Station. So coming to sustainability, we know the meaning of sustainability. It's a buzzword now, right? We say like everything that we should do should be sustainable, meaning that whatever we are planning or doing, it should be able to meet our own needs, but at the same time, it should not compromise the ability of the future generation to meet their own needs. So if we are like exploring or extracting resources from around Earth, it should not be that we are just exploiting and just finishing up all the resources for such that the future generations don't have anything to do, anything to meet their own needs for that. So earlier in the past 20, 50 years, the people didn't really understand why we should be sustainable in our actions. But now we are facing the consequences of these mindless actions. And now we want to be sustainable in everything that we do. So our action should be such that we respect the three pillars, which are the economic, the environment, and the social pillars of the community. And same goes for the space exploration. If we are exploring space, we should be very mindful of not to exploit, but rather just explore in a way that it should not finish up or deplete the resources, say, for example, of Moon, or we do not damage the environment of Mars. And because then it will leave all the other future generations have nothing to explore with. So that's something that we should learn and we should implement in our actions. And that's where robots can come into play. So why do we use robots for space exploration? Can anyone answer? You can, let's make it a bit interactive. You can type it, or yes, raise your hand. Yes, Guru.
Ma'am, we have only less fuel. If we use more fuel for space exploration today, tomorrow we will meet. Uh, Tomorrow we will not have such fuel.
Fuel as in? What fuel? Like fuel for the rockets?
Yes, ma'am.
Ma'am, my answer is that due to sending the robots into the space, if we send a human onto the space, if the mission fails, there is a life loss. And if we send a robot, there will be not the loss of any life. So that will be better to send a robot.
Anyone else? Yes, absolutely right. Both Guru and Anshu. So Guru, not just in terms of fuel, but in terms of any resource, if we are sending a human mission before even knowing what that planet or that environment holds, we are just exploiting and, we are spending resources unnecessarily. So instead of sending humans, if we send robotic missions, the amount of resources that we are putting in, the amount of money, the amount of whether it's fuel or even in terms of planning, everything is reduced at a much lower scale. And Anshu, yes, definitely the risk factor gets lower if we are sending robots to space before humans. We have to send humans, of course, but robots make it more sustainable. So yes, the first thing is space is very hostile. The environment of space has radiation, microgravity, vacuum, extreme temperatures, extreme pressure, and these environment is not, very. It's not very kind for humans to work with. So it makes it more reasonable to send machines or robots to explore space. Difficult task there. Because of this such extreme conditions in space, humans have to wear a lot of protective gears, and they have to put in gloves, they have to put in suits and a lot of other things, and that kind of limits their capability to work. And that's where robots come in. Robots can help in construction of habitats, in on-orbit servicing, in fixing debris or capture of debris, and also work in very infeasible locations. Of course, robots can get, damaged, but the risk is much, much lower. Cost effectiveness, already mentioned. Deploying robots are less risky and and also cheaper and than launching humans in unknown environments. Mental state is very important. Humans as a species is a social animal, and we really don't adjust very well in long duration space flights or isolated areas. So robots kind of are better in that terms if we program them in a way that they just work in a robotic manner and just keep on doing what they are allocated to do. There is a way that you can, overcome that mental state that humans face during these kind of conditions. So overall, robots really is a good solution for sustainable exploration. But in the long run, we definitely need humans, and we need humans and robots to work together. So there are various applications of robotics in space. These are some of the very common applications that that I'm presenting, but there are, as you know, the space robotics field grows, we will have more and more applications in this field. And for example, in Japan, we have robots here in almost every phase of life, like whether it's entertainment or in education or in restaurants or nuclear power plants, disaster response, and all these kind of applications that robots are very frequently used. Just like that, we need to have robots in space because that's an extreme environment and it makes much easier for robots to work in these kind of conditions. So deep space exploration is one of the application of robotics. So if we want to explore really deep, like far away planets like Mars or Moon, or the icy moons like Enceladus and Europa, robotics is the way to go. If you want to survey the planetary surface, also Mars or Moon, having robots on the surface is a much better idea. Assembly and construction, already mentioned, robots can help in assembly and in situ resource utilization. So in situ resource utilization is a big topic that's coming up. Like when we go to Mars or Moon, we don't want to take all the stuff from Earth there because that's not very sustainable. Instead, we want to use the resources that are available on Mars or Moon and build out of that, whether it's habitat or some solar panels or any kind of facilities. So there you can have robots to build it, to do some 3D printing using the regolith or the sand of the moon. Then the fourth application is debris capture and services. Of course, this is a very important topic, an important application nowadays because we have so many debris in the low Earth orbit, and we need to mitigate the amount of debris that we are producing, but also remove the debris that are already there, and or probably like refuel or repair the already defunct, dysfunctional satellites that are there. So we can have robots doing that as well. We can have robotic arms and orbital robots going around and fixing these satellites or just removing these satellites. Robotic landings, if you have seen the booster landings of the SpaceX rocket, you might have seen how precisely they can come down and stop at the landing position. That's also robotics technology. It uses a lot of computer vision and autonomous navigation and motion planning to just go back to the position that it's supposed to go. So these are some various applications of robotics in space. And space robotics can be divided into two such categories. One is the orbital robots and one is the planetary robots, based on the applications that I mentioned. So planetary robots, orbital operations and services can be the application, space debris removal, microgravity research. So we can also have robots to do different kind of biological or physical or morphological experiments in space. Automated experiments, because microgravity has this vacuum and extreme conditions, and these conditions we can do many different kind of scientific research. Planetary robots are robots that are used for deep space exploration or for planetary surface exploration or for sample return of a certain kind of celestial bodies. And these are also the precursors of future human expedition to remote celestial bodies. So if we are planning for Artemis mission, for example, we are not just sending humans directly to moon. Instead, we are planning to have robots initially set up the base, do the survey, and then send humans later. So it's like precursors, and that is how you plan a long-term goal. For example, the Apollo missions that happened in the 1960s and 70s, these missions were a result of the space race or the Cold War between USA and USSR. And they were in a mindset to compete with each other. And they thought of like, okay, we will send our humans or our citizens to moon, and we will be the first ones to do that, to put our flag over there. And that's why after certain number of missions, the missions didn't continue because they didn't have any more funding. They didn't think about the long-term goal. It was not sustainable. And it stopped in the 1970s, and now it's 2022. It's been over 55 years since the last Apollo mission. And we are still trying to figure out how to go to the moon, how to go back to the moon. So this should not happen, whether in terms of moon or whether in terms of Mars or any scientific exploration. It has to be sustainable and long-term planning. So going the robotics way is much more sustainable. So coming to the different space robotics challenges in this, like the different challenges in the space robotics research. Of course, there are many different challenges, but I'll cover 3 main topics, which are very essential nowadays, and something that you can think of getting into for your research as well. So mobility and control, or mobility and locomotion. We have different types of robots for planetary exploration. Okay, another thing is my expertise is not orbital robotics. So you'll not find a lot of things about debris capture or active debris removal, but I will give some information about the different companies and the research universities that are working on this topic. So you can definitely go out and check that. So coming back to the planetary robotics, we have the wheel robots. So as you can see here, wheel robots are just rovers which have wheels, and they move around on the surface of the planet, the usual way. And here you can see like 2 rovers moving. The video is not working, but yeah, the 2 rovers are there on a desert testing place, and it's one type of locomotion that's used. Then there is limbed robotics. Limbed robotics is used for like climbing a wall or climbing the cave or some unfeasible locations where the rover with wheels cannot move around. So that's where we use limbed robotics. And these limbed robotics are mostly inspired by bioorganisms. So for example, spiders or cockroaches or lizards or even humans trying to climb, like the climbers or mountaineers who are trying to climb very steep slopes. So these are the different kind of organisms that even dogs. And if you see the Boston Dynamic spot, it's actually inspired by a dog, and it's supposed to go to be launched to moon in the next couple of years to explore some areas that are inaccessible by rovers. Then flying. For flying, you can have flying robots for where the atmosphere is a bit dense, like Mars and like Earth, Mars, Titan. So Titan is the moon of Saturn. Yes, Saturn. And you can have actually helicopters or octocopter kind of robots flying around and exploring. And here you see the Ingenuity helicopter, which is flying around right now in Mars and just exploring much larger area than just the Perseverance rover, which is a wheeled rover and moving in a much slower pace. So next is tumbling or bouncing robots. So There are certain celestial bodies like the comets or the asteroids or some of the moons have very low gravity, like gravitational pull. So these are microgravity bodies, and you cannot really have surface robotics working on those planets, on those celestial bodies. So you cannot have rovers roving around or limbed robots walking around, because then it just doesn't get the enough traction and enough pull to move around these bodies. So instead of that, you can have tumbling or like bouncing kind of robots. So if you check out the Hayabusa 2 mission Minerva and mascot, I'll write it here. Minerva. Robots. So these robots are actually tumbling robots, which fell on the asteroid Ryugu, and how they move is like they try to change their center of mass and just move like that's the surface, and then it just tumbles on the surface of the celestial body. I recommend you to like go watch the videos of these robots. Unfortunately, this video is not working, but yeah. Floating robots or buoyant robots are used for bodies which have ocean or water. So the icy walls, like the Europa and Enceladus, it has been proved that they have an icy surface, but they have ocean beneath it. And to explore these water under the icy sheet, we need some kind of like robots that can actually float around. So NASA is already developing these kind of robots called BRUIE, B-R-U-I-E, BRUIE, which can float under the sheet of the ice and explores or collect sample under that. Then we have gecko or sliding kind of robots, like snake kind of robots, which can go into very narrow areas like fissures or pits in whether it's moon or even in terms of like the icy walls, where they have very narrow fissures and you can only have very narrow robots to go into it. So that's another kind of locomotion. That's the sliding or serpentine kind of locomotion, where robots can go inside and then explore those kind of infeasible locations. So these are some kind of mobility and locomotion systems for planetary exploration robots. Any questions so far? Okay. Then coming to the next challenge is autonomy and intelligence. So we want our robots to be autonomous, because we cannot have, we cannot keep sending data or signals or orders to our robots to do something. So for that, we have to give enough capability for the robots to, understand the environment and think about the environment and also act according to that. For that, we have to give, just like a human baby would develop along the years. So by understanding the environment, then trying to learn, think, and then accordingly act to the situation. Just like that, we have to equip our robots by giving them the different types of sensors, different type of actuators, different types of processors, so that it can understand the environment, It can position itself, it can navigate safely, and also detect the different types of regions of interest and measure and collect data and validate all of those. All the tasks can be done autonomously or semi-autonomously. So this is a major, if you know about, you might have heard already about artificial intelligence, reinforcement learning, deep learning, and convolutional neural networks. So all of these are advanced computing concepts where we are basically trying to give our machines enough capability to be autonomous, to think, to sense, think, and act accordingly. And in the process, also learn. So train itself and learn what is good, what is bad, how to act, how to not act. Okay. What types of microgravity research by? Okay, that's a good question. So there are many different kind of microgravity research that's done by orbital robots. First research that's done is like fixing or refueling of other satellites or other other client satellites, refueling or repairing. Also capturing mechanisms have been tested for on orbit or orbital robotics. In terms of more microgravity research, mostly the research has been done on board the International Space Station. So International Space Station has different kind of robots in itself. Like there is this Dexter a robot, which is a robotic arm developed by the Canadian Space Agency. It's just outside the International Space Station, and it does quite a number of microgravity research as well. So it tries to fix the solar panel. It tries to release, test many different kind of release mechanisms or capture mechanisms. Then there are different robots inside the International Space Station, such as there was the Robonaut by NASA, which did research, which helped the astronauts to kind of do different kind of tasks, like fixing some screw or fixing a machine, or just being an assistant to the astronauts inside the International Space Station. So that was also a technology demonstration in microgravity conditions. Yes, Fatasa, in-orbit servicing is a research that's going on for my orbital robots as well. So coming to sample collection and analysis, some of the data, so we don't just want our robots to just go there and do nothing, right? So we need to collect different kind of samples in different means and different methods. So there are various kind of sample collection mechanisms that can be implemented depending on what is the objective of the mission. So first sample collection that I've listed here is like collecting the samples from the asteroid. So if there's an asteroid, as I mentioned, it is a low gravity body, so you don't really have the pull. So the robot cannot just go there and stay there and collect the sample. Instead, it has to have some kind of mechanism where it can suck in and just move away very quickly. So here is the Hayabusa 1 satellite. It's a simulation of Hayabusa 1 satellite. I'm not sure why my videos are not working. Okay, yeah. So this is the Hayabusa 1 satellite, and just a minute. Okay. Okay, so here you can see how the robot is very slowly coming down to the surface and then just touching it and moving away. It's a very, very short time. And here you can see the actual mechanism. See, it drops a pellet. There is some sample that comes up because of that impact, and it sucks in that sample and then collects it and moves out. So this is one kind of sample collection mechanism that's usually used by low gravity robotics. Then there is also a drilling mechanism, which is used by surface robots on Mars. So both Perseverance and Curiosity rover, they have this kind of mechanism where it drills the sample and then collects it and then analyzes it. So drilling is a kind of sample collection mechanism as well. Then there is the scooping method. So scooping is like a scoop you have, and then you just collect that sample from the surface and then analyze it with the number of onboard sensors and the onboard instruments that you have, like the Raman spectrometer and the SuperCam or the hyperspectral cameras and all the different kind of instruments that you have. And usually these survey robots or the scientific robots on the planetary surface, they are kind of a bus or a lab full of instrumentation. So full of automated instrumentation. So you do not need a human scientist to be there to analyze the sample. So it's just everything is automated and it just analyzes it, and certain things that it cannot analyze, it would send the data back to Earth, and then scientists here on Earth can analyze it. So now my videos are working. I will just show you briefly these videos. So rover, and then there is the walking lemur robot by NASA. This is the flying one. And this is the tumbling mechanism. So you can see how it's changing the center of mass and then just moving. Yeah, can you see this? There is this kind of lever which changes the position, and then you have the change in center of mass. And that's Brui, which is a Quant robot under the surface of Antarctica. Actually, this is done a test in Antarctica. And a sliding robot. So coming to how much you know about space robotics or how much you have heard so far, let's have a trivia. Can you name some of the first space robots that were deployed? You can raise your hand or you can write it. Any of the first space robots. I'll give you some time. Anyone can raise your hand. For space robots, you can go back to the 1960s and 70s. No? So these are, yes, Kushi, go ahead. Kushi? Sputnik 1, okay. Okay. Voyagers. Okay, so Sputnik 1 was the first satellite that was launched actually this week on the 4th of October. And that's one of the reasons why we celebrate the World Space Week. But it was not a robot. So robot is something that can help you do some tasks in a repetitive manner or do some kind of simulation or manipulation in a area where you cannot have humans. So in that sense, Sputnik is not a robot. So it's just a spacecraft with an antenna just beeping information back and forth. So, but it didn't have any kind of, camera or any kind of manipulator or anything that you would say it had some robotic technology. I don't know about Sigyan, actually, Yash. I've never heard about that. Voyagers, yes. Voyagers were one of the first spacecrafts, but again, it's not robotic. It had the communication modules, some cameras to send images, very basic cameras, but no manipulation or no computer processing or computer vision implemented in it. But here you can see some of the robots that were launched in very early stages. For example, Luna Code 1 in 1970 by the USSR. And it is one of the very first rovers that traveled on another celestial body. And it had like wheels. Again, wheels is kind of manipulation. It had the antenna and the different kind of sensors on board to understand and study the surface of moon and relay the data back to Earth. So that's something that you would have, like a robotic technology on board. And Luna Code is one of the most successful robots that so far. Like it was launched in 1970, and it is a kind of heritage to say. Viking 2 was a lander on Mars, and it landed at a place that was like supposed to harbor life on Mars. So it landed there, it had a robotic arm, and it did many kind of sample collection and analysis. So that's where your robotic technology comes in. It a proper lander and a robotic arm with lots of sensors to analyze and study. So this was in 1975, you can think and see. Then there was the Venera 9 in 1975. So USSR launched a series of robotic spacecrafts to Venus from Venera 1 to, I think, Venera 10 or 11. But most of them failed because we still didn't know what was the condition in Venus, and we didn't know how hot it is or how dense the atmosphere is and all that. And most of the robotic spacecrafts failed. But Venera 9 was one of the successful spacecrafts that went through the atmosphere of Venus and collected a lot of data, gave back like information, what is the composition of the very thick atmosphere of Venus. And then it went and landed on the surface and even gave back data from the surface and did some experiments on the surface. But it stayed only for a few minutes, but that was enough for all the different kind of information that was required. So it was a robotic probe. Mars 8 was a lander. Again, USSR launched a series of landers on Mars, and they had lots of failures. But then there was this Mars 8 lander, which again had manipulation and collected data and then analyzed the data on board and sent a lot of images and a lot of technical data as well. In the 1960s, if you know, during the Apollo mission 15, 16, 17, there was this car called Moon Buggy, which the astronauts took to moon to drive around the moon. And that's one of the robotic spacecrafts as well. So it did not have a lot of autonomy, but it had wheels, and it could, drive the robots, drive the astronauts safely. It didn't. It was not. It did not have a self-driving mode or anything. The astronauts would drive them around, but it could. It had this different kind of manipulators where it could cover the astronauts or steer in a way that it does not hit a rock or something like that. So that was one of the early robotics. And of course, the lander, the Apollo lander, was also an early robotic spacecraft. Then there was more recent, in the 1990s, was the Rotex arm, which was by DLR to test it was a technology demonstration on board the space shuttle, and they tried to see teleoperation or telerobotics. So the scientists were on Earth, and they were controlling this robotic arm that was in the space shuttle in space. And it was a successful demonstration of a manipulator arm for on-orbit servicing. There were these twin rovers called Sojourner and Pathfinder to Mars. And these were like micro rovers, which also moved around the Mars surface and collected data and gave back a lot of information. And then there was the Spirit and Opportunity rovers that were also sent, also the twin rovers to Mars. So these are some of the very early robots. The one that you mentioned, Perseverance and Curiosity, those are the current space robotics missions. So there are certain robotic missions that are ongoing right now as we speak, and Curiosity is one of those. It's one of the very early, one of the most successful robotic mission. It was launched in 2008 with the plan to have it only for 2 years, and now it's over 14 years and it's still working fine. It does have some damages on the wheel, on the camera, but it is doing its job at the Gale crater, and it's collecting samples, giving back a lot of information about Gale crater. And that shows how robots can be sustainable exploration. From like, you can have a long-term goal and just having a robot on the where you want to explore. Perseverance and Ingenuity. So Perseverance rover is the Zero crater to trying to find, signs of life, and also trying to do in situ resource utilization, like trying to use the atmosphere of Mars to produce oxygen. And Ingenuity is the helicopter, as I mentioned. It's going around, flying around, taking pictures. Zhurong is a robot by China, and it was launched in 2020. And again, we don't get to hear a lot about the Chinese missions, but this is one of the very successful mission. And very recently it was in the news that it found some very important information about the ancient Mars conditions. So Mars probably went through a very catastrophic flood, like a very big disaster that kind of left a lot of like the banks of the rivers or the streams were washed away. So it made this kind of discovery from its observation. And it's a rover, it's moving around and collecting data and doing on-orbit sample collection. Then there is the Dexter robot, which was again built in 2002 by the Canadian Space Agency. It's on just outside the International Space Station. It has many different kind of tasks like fixing the solar panels, capturing satellites, or releasing satellites, or capturing the capsules on which the astronauts come to the space station. So do you know of any other current space robots? Any idea? Very recently, there was a news about the LSRD is not launched yet. Yeah, Chandrayaan rover, not yet. So there was a very recent news about the direct asteroid redirection test, DART. So this robot was and is it hit this asteroid and then tried to change the course of the asteroid, just demonstrating that we can have we can change or modify the trajectory of near Earth objects if needed. So that was one of the current robots that are there. Yes, Astrob. Yes, Astrob is on board the International Space Station, and it is a robotic platform where you can have where you can do like many different kind of microgravity research, even send your softwares and get tested for orbital robots. So Astrob, yes. There's also Simon, which is by Airbus TLR. So Simon is an artificially intelligent equipped robot that is on board the International Space Station, and it acts as a kind of friend for astronauts. It chats with the astronauts and, kind of mood uplifter, or just as a person with whom you can chat. So it has its own moods and everything. So Simon is one of the current robots. Can you name some of the future space robotics missions? So I already mentioned, you did write about the Chandrayaan rover. Yes. Can you name the rover, the Chandrayaan rover? Yeah, Pragyan. That's the name of the rover. So Chandrayaan 2 had the rover called Pragyan and the lander Vikram. Unfortunately, it failed while landing, but Chandrayaan 3 will have the similar systems, Vikram lander and a Pragyan rover, where it will land on moon and hopefully in a safer and successful way this time, because there were some mistakes that happened during the landing, which will improve. Mitra, yes, Mitra is one of the future space robotics missions on board the Gaganyaan mission. But there are many more missions that are coming up, so it's very exciting. So ExoMars mission, which is a mission by the European Space Agency, where they want to send this rover to Mars and dig or drill 2 meters deep, because if there is some signs of life in Mars, it would be deeper into the surface. So that's why they want to dig in deeper and collect samples. Then there is the MMX mission coming up, which is by JAXA and the French and the German Aerospace. So MMX is Martian Moon Exploration. So Mars has 2 moons, Phobos and Deimos, and this spacecraft is going to the Martian moons to explore these Phobos and Deimos. But this is not the robotic part. The robotic part would be the lander or the rover that will land on Phobos, and Phobos is the bigger moon. And I can show you a video of MMX rover. Not sure. Okay, not sure why it's not working. Okay, anyways, I suggest you go and watch it, the MMX rover, and I'll share the link here so you can check it out. Yeah, that's the link. So the DLR page, and you can just check out how the rover, it's a hybrid rover, and it lands on the surface, and then it opens up its limbs, and then it walks, and then the wheels open up, and then it roves around. So Phobos is, again, a low gravity body, but not as low as the asteroid, so you can kind of move on the surface. So it's a simulation that is on the video, because we still don't know what kind of environment is there in the Phobos. So we are like testing different kind of different kind of simulations by changing the different gravity value, and that's one of the simulations that are there by DLR. Then there is the Dragonfly mission, which will be launched in the later half of this decade, and it will be going for Titan, the moon of Saturn. As I mentioned, it has a very thick atmosphere, and you can fly different kind of robots in that area, and it's going to analyze the atmosphere. It's supposed to have like kind of chemical atmosphere, so methane and some organic atmosphere and also lakes. So this robot will be flying around, collecting pictures, collecting samples from these kind of lakes. The Viper mission is a lunar mission, which is in collaboration with NASA and different private companies, and it's going to the south pole of the moon, and it will be like trying to find if there is water ice in the south pole of the moon, and if it is there, it will collect the sample and then analyze the sample. Then Chandrayaan 3, I already mentioned, and Europa lander, which is a faraway mission that's planning to go to Europa, which is the moon of Jupiter, and it's also icy body. So it's supposed to like land on the surface of the ice and then leave some robots that can go under the surface of ice. So as you saw, like there are so many space robotics missions planned and so many robotic space missions that are happening. We see there are many different challenges, some of the challenges which I already mentioned, but there are many different research topics that can be taken up for space robotics to make it, sustain for longer terms. The mission should be more planned for to sustain for many, many years, and also to work with humans. So, of course, protection from harsh space environment is one of the topic that's in trend right now. We need to protect our robots from being damaged from the extreme environment. Mobility in different terrains, we already covered that. Mass and power limitations is a major problem for all space missions. We cannot have too much of mass to launch, so we need to make smaller robots that can do much better tasks. And same for power. We cannot have heavy power or heavy solar panels to sustain our robots. So it has to be lighter, but also efficient. Simultaneous localization and mapping. It's a big research topic right now in the robotics community, not just in space. But yes, we need our robots to understand where it is and map its location so that it can safely navigate around. Human robotic interaction. So if we want, as I've mentioned multiple times, if we want sustainable space exploration, we need to have humans and robots working together. So this is a major human robotic interaction research topic. And if you are interested in this topic, definitely check out some of the research teams that are working there. Remote operations is a major hurdle for space robotics. We cannot have, sending signals and orders every time because there's a lot of delay in that. And that brings us to making our robots more autonomous or more intelligent so that they can do most of their tasks. Debris stacking is a major problem. Before debris capture and debris removal, we need to track the different debris that are there. And for that, we need to have a proper, more reliable technology. Swarm and multi-agent exploration. So instead of having just one rover or just one robot to explore an area, we can have multiple agents, but at the same time, that increases the complexity of the control of the coordination between these agents. So that's a topic that you can look into. Modular robotics, so plug and play, is now becoming very popular, and we want our robots to be modular so that they can do different kind of tasks without actually, having more dedicated design. But you can have one design or like a set of designs to conduct multiple tasks so that the robots can just form different kind of, take some forms and do the task that is required. Self-repairing robots, like the robots are definitely going to get damaged in the harsh environment, but we cannot always go and fix these robots. So there's research going on how the robots can self-repair themselves, whether in terms of like doing some kind of first aid on the robot itself, or just some kind of materials that can repair itself over time. Shape changing and origami robots. This is again for areas which are inaccessible or unfeasible. So you can have different kind of shape changing robots that can go into areas that are not usually accessible by humans or by bigger robots. And in situ manufacturing and services is a major challenge where we need robots to work with and work in, and we need to have, more reliable, more robust robots in this sector. And to give you a glimpse, space robotics is a growing market. Not many students actually know about it because there's a lot of information about satellite and rockets, but space robotics is a major industry, and a lot of private companies along with the space agencies are coming into this sector. So here you can find a number of companies that are in this sector, like the Astrobotic, iSpace, as I mentioned. All of these are actually spin-off of the Google Lunar X Prize competition. And then there is the Honeybee Robotics, which is working on on-orbit servicing, astroscale, clean space, working in the space debris capture and removal, asteroid mining, planetary resources. These are robots that are working for exploration of the asteroid or collecting resources from asteroid and also from moon. And then Gitai is a Japanese company that is developing lunar robotics and also robots for the International Space Station. So you can stay updated with different kind of robotic trends by joining different organizations that are running space robotics webinars or workshops. At Spaceonova, I give research internship and training program, which is a 6 weeks program, and I teach the basics of space robotics. So starting from what is space robotics to how to program, how to build, how to design, and like the basics that to start with, and then you can go into after the program you can go into advanced research on the different topics that I already mentioned. And you can go to this link, which is the QR code, and you'll find a list of different universities that are working on extreme environment robotics. So extreme environment robotics is very directly related to space robotics. So space robotics is a very small group still. So if you can go for extreme environment, even that's fine for to move into robotics. And with that, I would like to end. Sorry, it went a bit 10 minutes over, but yes, you can follow me on LinkedIn and my research on ResearchGate. And here, this is actually my team from Spaceonova, and we went to Paris. We went to Paris to present our papers on space robotics. Yeah, so now I'm open to questions.
Thank you, ma'am, for this wonderful presentation. Now I think we can move on to our Q&A session. So participants, if you have any questions, feel free to ask your questions by turning on the mic, or also you can write the questions in the chat and I will read out the questions. Okay, so we have got from Vishab Raval, what kind of robot framework were used in space robotics? Does ROS has applications regarding this, and what kind of technical skills one should opt for getting into the field of space robotics? As I am pursuing mechatronics, engineering, and fond of space robotics, so I'm just curious.
Yeah, thank you, Vishnu, for your question. Yes, the basic of all robotics is right now is to learn ROS. So even for space robotics, we work on ROS. Initially, it was ROS 1. Now we are moving to ROS 2. So what kind of technical skills? Yes, what kind of technical skills? Space and robots both are interdisciplinary. So even if you are from mechanical or electrical or electronics or computer science or mechatronics, you can always find a technical project on robotics or even designing, so 3D modeling and all that. So if you are pursuing mechatronics, that's a perfect fit for robotics, and you can always go into space robotics research from there. So yes, definitely, make your be strong in your Python and C++, and develop some projects on ROS, and you can easily get into the space robotics domain.
So we have got another question from Guru Pandian. Would we know more about the space robotics course? I think he's asking about the pathway of getting into space robotics.
I think he's asking about the Spaceonova space robotics course. Is it that, Guru? Mahat, you can always reach out to me on LinkedIn. So you can just search Shreya Santra and you'll find me. You can send me a question there. Yeah, and Guru, about the space robotics course. So as I mentioned, we cover everything from the basics to start with. We give a project to the students. It's a team project, and they have to either design a robot for Moon or for Mars, and kind of cover all the topics that are taught during this course. So they have to design and develop the entire robot. It's a virtual course. So right now it's virtual. It's a 6 weeks course. So I cover whatever could be done in a virtual way. So designing, 3D modeling, then programming, learning ROS, then the systems engineering, control architecture, the electronics architecture, the communication protocol, the communication link and communication budget between the robot and the Earth control, and all the different kind of subsystems that are required to design a robot. So it's that kind of course. It's open for all different different backgrounds. So yeah, if you want to start your journey in space robotics, that's a good way to go. So we have, we'll probably start the next batch in January. Currently, we have a batch going on. We'll start the next batch in January. So keep an eye at the page of Spaceonova, and you'll see when we post about it.
So the next question I've got from Mahat is, which space organization was pretty successful when talking about space robotics, except NASA and Roscosmos?
It's JAXA, Japanese Space Exploration Agency. So if you can look into the different projects that JAXA has done, the Hayabusa 1, the Hayabusa 2, then there is so many rovers are planned. Also, the Chinese Space Agency is very good with the space robots. They have this Chang'e mission, and they had the lunar rover that landed on the dark side or the other side of the moon, and they sent back many different kind of images which were not known earlier. So the Chinese space station is also very successful in space robotics. Does Robonaut control the ISS? No, Robonaut is just a robot that was on board the International Space Station to help the astronauts in fixing the tools, the devices, and just as an assistant.
So we have got a question from Yashraj. Is space robots use only solar energy as a fuel, or for different types of working purpose, or they use different alternatives?
Okay, that's a very good question. So by fuel here, you mean power, right? So solar energy is not the only source of power, but also nuclear power is used for space robots, because once you go in on Mars and beyond, solar energy doesn't work. So like the Perseverance rover has the nuclear power on board. The Voyager spacecraft, the Cassini spacecraft, the all the other deep space robotics have the nuclear power on board. Giving an example of how solar energy is not the only power source, if you see the Philae lander, Philae, 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 it landed on the comet 67P, and it landed at a point where there was no sunlight. So comets are also low gravity bodies, and they are always like moving around. So if it landed at a point where there was no sunlight, and the mission kind of failed because it couldn't do anything with its solar panels. So it's preferable to have nuclear for these kind of long-term missions. Plutonium dioxide. What do you mean by plutonium dioxide? I don't think plutonium dioxide was used. It was the RTG, like the radioisotope thermoelectric generator, but I'm not sure if it was plutonium dioxide or something else. So RTG are the are the nuclear power modules.
So participants, if you have any other questions, please feel free to ask your questions. Okay, I think we're done with our questions here today. So first of all, thank you, ma'am, for this wonderful presentation and for this.
Good evening. May I ask one question?
Yeah, surely.
Yes, go ahead.
Good evening, ma'am.
Good evening.
For the becoming one of the scientists in astronomy field or astrophysics, my daughter is studying in 5th standard. So how can I give support to become astrophysicist, like in robotics, as you are studying?
Okay, just let her study all the different subjects that she's interested in. If she's interested in astrophysics now, she might be interested in something else 5 years from now. So just support her in whatever she is interested in. You can help her in attending the different kind of events that are happening that these organizations conduct. Like there is the National Asteroid Search Campaign, where school students actually search for the asteroid and name the asteroids. So you can help, like, support her in participating these kind of challenges where she gets to know more about everything about space and not just astrophysics. So and then she will decide on her own.
Thank you, madam. And I'm asking about the qualification example, like mathematics and science. So either the priority in PUC science and BSc, like that. So the channel I want to guide her in education purpose.
I think either way it's fine, BSc, MSc, or BTech, MTech, and PhD, or even, engineering or science. Either way is fine.
Okay, madam. Thank you. Thank you very much.
Yes, Shani, can you give examples of sliding robots and how they move around in terrains? Yes, I might have a video, but on Earth. Basically, they have these kind of sliding or snake-like movement. So they get, attached to the surface and then try to move along the surface. So if you see this link of Kyoto University, they have this extreme environment robotics lab, and they also develop these kind of robots. And these robots are also used for disaster response. So, for example, if there's an earthquake or a major, disaster where there is very less opening and you cannot have big robots or you cannot have humans to go in, you send these kind of serpentine robots with a camera near the face. So these robots can go inside and see if there is a human or any kind of living organism inside that might be stuck under the debris. So again, like there's a lot of research going on in the movement of these and the control strategy of these kind of snake robots. So do check out this video, this link I shared. I think there was a question earlier from Dheeraj. What is soft robotics? Soft robotics is more like using materials which are flexible and then building robots out of it. So mostly these kind of robots are used for marine exploration or again disaster robotics, where you need to be very flexible to reach inaccessible areas. And yes, soft robotics is used there. For space, yes, we need to use soft robotics, but the material is a big concern because you cannot just have anything or everything in space because it is not very safe. Say, for example, a flexible material that can work on Earth will not work in space due to many reasons, with the pressure or microgravity or just the radiation. It can get spoiled there. So yes, soft robotics is also a research domain that you can look into, and maybe for space applications specifically. Any other questions? I hope you had some new information about space robotics.
I think we don't have any other questions. So firstly, thank you, ma'am, for this wonderful presentation and for sharing so much information about space robotics, about the domain, and taking your time to answer all the questions of our participants and letting them know how to know more about this domain and how to get into this domain, and if they want this as a career path in future. So we are really grateful to have you here with us today. So thank you for being here with us, and also we are really grateful to all our participants for supporting us and making this session, a live session, a successful one throughout the session. And thank you. And lastly, before, I would love to request everyone to turn on their camera once so that we can take a picture for a memory purpose. And okay, so we have taken the pictures. Thank you everyone for being here. And also we have another session with Dr. Mitra tomorrow on space sustainability. So don't forget to join the session and learn more about space sustainability. Also, we have streamed this session live on YouTube. Go and check out the whole session if you have not been able to attend the session from the very first. Let us know how much you have liked the session on the social media, and let us also know how we can get better at organizing these sessions and what can we do more. So I think with this, we can end our session here for today. Thank you, everyone.
Thank you very much, and thank you everyone for attending. So yes, attend all these kind of sessions and you'll get to know more about space and all the different fields that you can get into. Thank you. Bye.
Thank you for a very nice session.
Thanks a lot, Mila.